All right, measures of dispersion, part one. Um, as I mentioned in the last set of slides, central tendency is just one aspect of our distribution. It doesn't fully describe the distribution. To fully describe the distribution, we need to bring in some other statistics, in particular measures of dispersion. Dispersion means to drive off or send in various directions or scatter. I think scatter is probably the better definition here, matching up to what we see statistically. Measures of dispersion really just get at how scattered our scores are. And when we say how scattered they are, we want to have a comparison point. How scattered are they relative to what? We're going to be asking how scattered are the scores relative to the measure of central tendency. And generally, it's going to be relative to what the mean is. So let's take a look at these two distributions again. Scores graded by the first graduate assistant and scores graded by the second graduate assistant had exactly the same mean, median, and mode. Problematically, we can see very clearly that these distributions of scores are different. If you look at the first GA, their scores ranged from 57 to 94. The second one had a much tighter range from 71 to 79. So we need to have a way to describe how spread out those scores are. And we'll see, we're going to get a measure that should be much bigger for the first GA versus the second GA. And we can see this graphically. These are the exams graded for the first GA. You can see measures of central tendency referring to the middle. Measures of dispersion, you can think about those as the ends of the distribution, or what we call the tails of the distribution. And if we put these two together, you can clearly see that the top set of scores, the GA1, is much more spread out than GA2, which is really tightly distributed. So what are the different measures of dispersion? I'll just mention them and then we'll get into them in more detail in a second. So again, we're focusing on the tails of the distribution rather than the middle. The measures that we'll examine are called the range, the interquartile range, the standard deviation and variance. That was much more important for our purposes, which is why it's in a larger font. If I was making these fonts act exactly relative to the importance for our purposes, that would be the only thing on this slide. And then we're going to talk about box plots. Those aren't actually measures of dispersion, but they're more a graph that brings in some of these concepts. And again, all of these are really only going to be relevant when we have data that are measured on an interval or ratio scale. So what's what? The range. That's simply the distance between the highest and the lowest scores. Highest quiz score for an English quiz was 25, the lowest was a 1, the range would be 24. Advantages of this is it's really simple. We can calculate this without even needing really a formula. Disadvantages, it's pretty thrown off by extreme scores or outliers, also not particularly useful in future calculations. Another one is the interquartile range. That's the range of scores that capture the middle 50% of the distribution. Specifically, the score at the 25th percentile and the score at the 75th percentile, the distance between those two. Advantages, it's not at all influenced by outliers. Disadvantage, it would be a pain to calculate by hand, also not particularly useful in future calculations. All right, the most important one, standard deviation and variance. Standard deviation is the big daddy or big mommy of all dispersion measures. It is really the only important piece in this, the only measure of really any consequence in this section. All the variances is the standard deviation squared. It has little use for our purposes, but we'll calculate it just because it's easy. Standard deviation of most common, most useful measure of dispersion, provided that our data follow a roughly normal shape. And what's nice about the standard deviation is when we have that normal shape, we're going to have we know that as a property that we'll learn later, that about 68 or a little more than 2/3 of our scores fall within one standard deviation of the mean. 95% of our scores fall within 2 standard deviations of the mean, And it's not on the slide, but 99% of our scores fall about 3 standard deviations from the mean. All right, I'll stop here.